In this lesson, we'll recap then the 3 steps to make and use a memory, as we discussed in class. And we'll use this sort of artistic version of a brain here with neurons. Some of them are brown, some of them are white. The first stage was encoding. A set of neurons respond to the learning event depending on the qualities of the learning event. So down here in the magnified view, we've got some of the neurons are shown to be white, and we'll say those are the neurons that are activated by whatever the particular learning event is. Should you be learn something different, a different set of neurons would be responding to the learning event. And we'll use this footage here of these engineered neurons that flash light to sort of give us a feel for what's happening in our brains. So in our visual cortex and auditory cortex and touch cortex and language areas, we've got sets of neurons that are responding to the details of the learning event. Next then is the storage phase. A subset of activated neurons will take part in making a memory of the event. These neurons grow stronger synapses with each other, forming a memory trace for the event. So again, it's a subset of neurons that responded to the learning event are now going to be triggered to grow stronger synapses with each other. We saw a video like this where we had neurons in a petri dish, and over the course of many hours and days, they began to grow connections with each other. So we see axons lengthening and branching, forming synapses on the dendrites of neighboring neurons. Now, this is extensive growth over the course of hours and days, as would occur during the development of the brain. But the same kind of thing happens when we learn. The neurons that were activated by a learning event are going to be triggered to strengthen synapses with other neurons that were also activated. Okay, so another aspect of storage, another way to look at it, is that the neurons with strengthened synapses form a network of neurons that prefer the stimulus in the learning event. So again, when we learn something and we get a set of neurons that respond, and some of them are going to form a memory trace of that event, those neurons that all responded form a kind of a network that represents the learned information. The final step then is retrieval. A cue reactivates the network of neurons that enjoyed strengthened synapses as a result of the learning event. The stored information is retrieved. So the idea here is that those very same neurons that were activated by the learning event and underwent that growth process, making stronger connections, forming a network of neurons that represents the information, that same network of neurons needs to be reactivated if we're going to successfully retrieve the memory. In a sense, then, when we're retrieving a memory, we're trying to recreate the brain state that occurred during learning and storage. So we can summarize then in sort of a school context what's happening when we learn and store information and retrieve. When we're learning information in our classrooms or in a textbook or in video lessons, we're activating sets of neurons, and some of those neurons are triggered to grow stronger connections with each other, and that's the storage of the information that we're learning. When we retrieve that memory, we're going to need to reactivate those neurons that formed the memory trace. And if we're successful at that, then we will successfully retrieve the information we're looking for.